In this video, we're going to look at Lewis structures and hybridization and molecular shapes. So we'll look at NO2 to start, nitrite, and so there's lots of different. You'll find if you look up instructions for drawing Lewis structures, you'll find there's lots of different sort of steps. But the overall step, at least the way I do it, is I count up the valence electrons. See if there's a charge. In this case, there's a negative charge, so we have to add an electron for that. So that works out to 18 electrons total that need to be accounted for in our Lewis structure. And we start with the least electronegative element in the middle, and at least initially put the other elements, or the other atoms, I should say, symmetrically around it. Put in a bond. As you know, there's going to be at least one bond between those atoms. And the next thing to do would be to complete the octet for the outer atoms. Okay, so I've drawn 2, 4, 6, 8, 10, 12, 14, 16 electrons. I have 2 more electrons to draw. Those extra electrons are going to go on the central atom. So there they are. Now we have a problem. Hopefully you recognize that the nitrogen does not have its octet. It only has 2, 4. Remember, each bond counts as 2 electrons. So 2, 4, 6 electrons around it. So the only way for nitrogen to complete its octet would be if it made a double bond with either of the oxygens. And if we put a double bond in, then we have to remove one of the lone pairs on that oxygen. So here we are. Now, okay, now you recall from when we learned about Vesper that if we have a lone pair on the central atom, it's going to push the bonding pairs further away. So kind of like the H2O molecule. You remember that the lone pairs on the O in H2O, I'll just draw that quickly. The lone pairs on the oxygen here push the bonding pairs further away, and we get a bent shape. Well, it's the same for this one. We've got nitrogen and there's the oxygens and the lone pair. Okay, now it's an ion, and you'll remember the convention for ions is to put square brackets around it and the charge outside. Alright, so let's write that in. The shape is bent. Okay, as far as the hybridization goes, we can figure out the hybridization on the nitrogen just by looking at this. It's got 3 regions of electric charge. The single bond region, the double bond region, and the lone pairs. That's a region too. So 3 regions of electric charge correspond to sp2 hybridization. Okay, and if you look down here, what this is the ground state. This is for the nitrogen. I should clarify that. That's for the nitrogen, the central atom. And we've done this orbital diagram to show where the electrons would be when nitrogen is in its ground state. So I'm running out of time with this video, so in the next one I'll show you what happens to these valence electrons during hybridization.